Chemists express the composition of molecules using chemical formulas. For example, we can represent the reaction of hydrogen with oxygen to give water molecules using samples, where hydrogen gas is H2, oxygen is O2, and H2O represents water. Usually formulas contain all types of atoms that the compound is made of. The chemical formula consists of symbols for each element in a compound, and it contains also numbers. These numbers can either represent the ratio of elements in a compound or the total number of atoms in the compound. H2 here means we have 2 hydrogen atoms, and O2 2 oxygen atoms. And for H2O, we have 2 hydrogen atoms and 1 oxygen atom. The formula that shows all elements and their exact number is called a molecular formula, and the formula that shows all elements and only their ratios is called the empirical formula. We use the term ionic formula for ionic compounds. Formula of ionic compounds are similar to the empirical formula. Let's first look at the molecular formula. The molecular formula represents the exact number of atoms in a compound. The molecular formula gives us information about the type of elements within a compound and their exact number. For example, hydrogen molecular formula is H2, water is H2O, and methane is CH4. From the molecular formula, we can deduce that the hydrogen molecule consists of 2 hydrogen atoms, and the water molecule consists of 2 hydrogen atoms and 1 oxygen atom, and the methane consists of 1 carbon atom and 4 hydrogen atoms. The atoms of the molecular formula can be visualized using 3 types of models: structural formula, ball and stick model, and space-filling model. In the structural formula, which is the simplest method used to represent molecular formulas, a line is used to present the bond between atoms. 2 lines mean double bond. For example, here we have 1 line between the 2 hydrogen atoms. This tells us that H2 consists of 2 hydrogen atoms that are bonded together by a single bond. As for carbon dioxide, CO2, the carbon is double bonded to 2 oxygen atoms. Each 2 dashes represent double bond. The other method of representing the molecular formula is a ball and stick model. From the name, you can understand that we use balls to represent atoms and sticks to show bonds. The ball and stick model shows the distribution of atoms in the structure and the angle between atoms, but it doesn't show us proportionality of atomic size. We draw all atoms as similar-sized spheres. For example, we can see that hydrogen and carbon dioxide are linear, with 180 angle between atoms. Finally, a space-filling model. This model shows atoms as spheres. Notice, we can't see bonds between atoms. This model is usually used to show the electron density of the atoms or the proportionality in the size of atoms. Here you can see that the carbon is slightly smaller than oxygen atoms. This model is the most accurate model because we exaggerate the distance between atoms in the ball and stick model. The space-filling model gives us the exact closeness between atoms. We see truncated balls held together by a snap. Let's look at the 3 forms of the water molecule, H2O. The structural formula tells us that oxygen is singly bonded to 2 hydrogen atoms. From the ball and stick model, we can see that HOH angle is 104 degrees. And the space filling model shows us how the 3 atoms fit together in space and their proportional sizes.